We're continuing on to part 3 of chapter 3 that deals with future value of annuity and then later sinking funds. This is sort of interesting because I just sort of moved into an annuity myself in my old age. And what is an annuity? Well, generally, it's set up through a bank or some brokerage firm where for a period of time you put in some money, and then after a certain period of time, at a certain interest rate, you are able to take some money out because that annuity has grown to a certain amount and they give it back to you. So, and again, your book has more information, and we're approximately on page 147. So here, someone for 20 years at 8.5%, compounded annually, that is once a year, puts in $2,000. So at the end of that first year, he has $2,000 plus that interest. And then that is carried over. And then the next year, another $2,000 added. And now it's $4,000 and more, and then so on and so forth. Now, your book goes through a rather long dissertation as to how they derive the formula. But basically, it ends up this, which is future value is equal to the periodic payments, and then 1 plus R. R is the rate, raised to the N, number of payment periods, and then minus 1, all divided by I, which is the rate per period. And you recall the I is the rate divided by the period, 4 times a year, quarterly or annually if it's 1. And number of payments, remember, is the times it's compounded during the year times the number of years. And this is something we went over in section 2. So just a little familiarization with the formula. So here in this formula then, for future value, we don't know that. For the periodic payments will be $2,000. The interest rate is 0.085 that we converted. The N, which is the number of payments, since it's going to be annually compounded, is 20. Minus 1 is in the formula. And then again, I happens to be the rate. Since it's annually, you don't have to divide it by anything. So again, what I would do is I would put 1 plus this. That just makes this a 1 here. Raise this to the 20th power in your calculator. Multiply it by 2,000. Once you do that, you're going to subtract 1. And then you're going to divide it by this. And when you do that, you end up with this answer. This is the future value of your total amount in this annuity that you've developed. And then they're asking, that would be the value, what would be the interest that you have earned on this amount? Well, you've put in for 20 years, $2,000, which is $4,000. So if you subtract your new future value, subtract 4,000, you have made interest of $56,754.03. Not too bad. All right, going on to our next example on page 149. It deals with sinking funds. And I'm going to go through the example with you in a moment, but I'd like to read the definition of what is a sinking fund. It says, in general, any account that is established for accumulating funds to meet future obligations or debts is called a sinking fund. So let's give the example of it here. We have some grandparents, nice people, that want to set up a fund for their child, their grandchild, to go to college, and they want it to be $80,000. Well, how much would they have to contribute each year for 17 years at 6% interest to be compounded annually, so that at the end of these 17 years they could have $80,000 for the child to go to college? Well, that's a pretty good help, actually. And the answer is, well, you would use basically the same formula we've been using, but now we know the future value is 80,000. What we don't know is the PMT. So we start putting information in which we get our interest, 17 years, and there's our interest again. Now we want to isolate the PMT, and we can do a little fancy algebra for this. If not, you can just use the formula down here, where you put the $8,000 or $80,000 here. I'm sorry, the $80,000 is the future value. This is what your periodic payment would be. Okay, so in a sense, that's what I've made here. The book gives you both formulas, but this is the one you've used because you've already solved it for PMT. So what goes on? Well, how would you solve it? What I would do is I'd put this in my calculator, 0.06. Then I would put a parenthesis in my calculator. I'd put another, I got to put divided by. That's this line. Another parenthesis, 1.06 caret 17 minus 1 parenthesis. That gets all of this then. You're dividing this into that. Keep that in your calculator. Don't write the number down, because it keeps all the places that you need. Now, what do? You multiply it by 80,000. Now, when you do that, in that sequence, you end up with this answer. And I was trying some of these with my calculator at home, and in some cases I wasn't putting that extra parenthesis there, and I didn't get the answer. So again, it's so critical how you put this into your calculator. And this is our periodic payment that once a year I have to put $2,835.58. That in 17 years I will have for my grandchild to go to college $80,000. And again, this was the formula we started off with, but when you're doing sinking values where you already know the future value, it's easier to use this formula. And again, you put this divided by all of this, then multiply it by that, and that will give you this. Again, it's critical that you're doing the practice to get you ready for your Quizmes and then later your test. One of the things I noticed is when I wrote this formula originally, I had an R there, which if it's annual, it works out, but it should be I. Again, I is the rate per period, so the rate divided by the period. So if this is 1, then I equals R. But correctly, that should be an I there. So we're going to do another example that's in the book. Here a company wants to replace some machinery in its factory. And the cost of the replacement is $800,000. And they're going to replace this in, let's say, 5 years. Now they can put some money aside at 6.6%, compounded monthly. They're wondering how much money would they have to put aside monthly for 5 years at this rate to end up with $800,000. So we're going to use the sinking fund formula. And that's what I have listed here. So we want to know what our periodic investment would be into our $800,000, our future value. And our interest now, again, is 0.066, but it's going to be compounded monthly. So we divide that by 12 to get the I value of 0.0055. So this is critical. This is something you have to do ahead of time so you can put this value into your equation. And then we also have to figure out what N is going to be, and that would be the time monthly times the years, 5 years. So 12 times 5 gives us our 60. So we have to put into our formula, and I didn't put the 60 there, did I? There we go. Okay. So I've put the I correctly, the 800,000 correctly. The I here, I'm going to add the 1 to it. Our N is 60 and minus 1. So again, the strategy of putting this into your calculator is super important. I would suggest you put this first, then a divided by, a parenthesis, then an inner parenthesis here, put this, caret 60, and of course your parenthesis around that, and then minus 1, parenthesis, hit enter, keep that in your calculator, multiply it now by 800,000, and your monthly investment over the 5 years, you would have to put $11,290.42. So using the sinking fund formula and being careful, because there's lots of places where you can make an error, again, that's where the practice comes in, and that's very, very important. Sometimes you wonder why you take a course like Math 1127, finite math, and deal with all these financial things. Well, our next example is probably one of the reasons you should take it and take heed. It's called Growth in an IRA, Individual Retirement Account. Many of you, you're not making a lot of money. In fact, you're spending money. But when you do make money later, get a job, and you're going to be working, you want to save for when you get old like me and others, your grandparents and things. Well, this particular fella had a job, and instead of the regular IRA, that you take money from your income and put it in this regular IRA, when you retire, that money is taxable. But you get it taken off of your taxes now, so you pay less taxes as you move on. Well, then they developed what is called a Roth IRA. Now, a Roth IRA doesn't reduce your taxes as you go along, but any money you accumulate in that, when you retire, is taxed free. You don't pay taxes on that. And of course, that's what my problem is. I had this original kind, and now as my IRAs come in, and I take the annual disbursement of the money that I must take, it adds to my taxes. And my taxes, I have to always pay extra money. But it's good that I have that to do anyway. So again, we strongly recommend you do the Roth IRA. And let's just look at what this person was able to do. He was able to put $2,000 into this Roth IRA a year at 6.85% interest. Now, he was able to do that for 10 years. And then he stopped doing that because his new job didn't make enough money, but he had that in his Roth IRA. But then he worked 25 years more. So what did that money that he put in there originally become after the 10 years plus 25 years, 35 years when he retired? Check this out. Well, we need future value that we've been working on, putting in $2,000 at this interest rate for 10 years, divided by that interest rate, and of course you're going to do this, multiply it by that, subtract 1, and divide it by this. You end up with almost $27,500. So in these 10 years, the $20,000 became $27,000. But now watch what that did when he just had this original amount of $27,437.89 that he invested, that he kept in there. And again, this is all tax-free. There's our rate again. Since it's compounded annually, our amount there is 25. Our N is 25. We're going to have 1 point this raised to the 25th power multiplied by this. And get ready for this, folks. He now has in his Roth IRA from only investing at a young age $20,000, it has grown to $143,785.10. Now, the key to all of this is to get something where you can get this type of interest. In today's economy and interest rates, that's super high. Nobody gets that. In fact, the only place you get close to this is in the stock market. From stocks. That's why a lot of people have put their money in stocks, and that's why right now they're doing very well. Right now the interest rate is very, very low. And so this type of interest is not heard of. But again, these are things that as you have knowledge of this, you're going to look at investment possibilities and what you might do as you plan for your retirement, which will happen, of course, it's a long time from now.